this section is entitled Installation, Configuration, and Validation. Install Kubernetes Masters and Nodes. So this section covers a range of topics related to the installation of Kubernetes. So if you recall, previously we already had installed Kubernetes on Amazon, but we used Amazon's Kubernetes service, which allowed for some deep integrations into Amazon services. It actually had integration with the VPC, and it was highly available. So we're going to reinstall a new cluster in Amazon, but this time just using bare EC2 instances. And it's really just meant to be a learning exercise. It's not intended to be a production EC2 deployment, just a learning environment. We could have done the same exercise just using something locally, like on our workstation, like Minikube or Micro K8s. But I wanted to at least minimally install it into a cloud environment, and Amazon in particular. There are a number of tools that will help automate installing actually a production quality version of Kubernetes on AWS, for example. And you can see that there's tools like Kops, Crib, and KubeSpray. Since our exercise is really more about learning just sort of the core fundamentals of how Kubernetes works and how to install it kind of more raw, we're going to use the built-in tool or the more native tool called kubeadm. So we're going to, so again, we're not going to, our goal is just to get up and running with sort of a basic cluster. So the first thing before you start installing it, you need to think about two things. One, you need to know what VPC you're going to be using. In this case, I'm going to use the default VPC, which provides for public subnets. And you'll see, for example, for me, this has a VPC and it has two subnets. Wait. This is the default one, 172.31. And when you go through the exercise of one of the things you need to do is you need to have a security group. So I actually went ahead and created a security group for this exercise, and it is this one right here. The key here is two things. For the security group for your instances, you need to have inbound rules. One, you need to be able to secure shell in, so I have it open to the world for secure shell. But you need to also allow any traffic to flow between any instances in that same security group. And so I opened up all traffic from any other source in the same security group, because I need to have the nodes and the cluster talk to each other pretty freely. So it's just kind of wide open internally. Okay, so in terms of the EC2 instances, let's look at that real quick. Looking at the instructions, you need to have enough horsepower on these to run it. So I ran these as, I created two of them, right? And they both are T3 mediums, so they're a little bit more power. And I used Ubuntu, and again, I talked about the security group already. So that's basically, you just need to get these up and running, just right out of the box with the latest version of Ubuntu that Amazon provides. The next step is you need to basically go into, let me close this down. There are some instructions on, you basically need to log on to those instances. On both of them, you need to do this exercise of installing kubeadm. It's a fairly lengthy process here, but pretty well documented. And at its core, the steps involve three major steps. One is they're going to have you validate some things, but the first thing you actually do is this bridge traffic configuration. So you need to do this section. Make sure you pay attention to this, because my Ubuntu environment or my instance didn't have this. So you need to call this first before you do this command. That was a little tricky. Another thing you had to do is actually install a container runtime. In this case, I used a Docker, and there was a separate instructions on that. I think if you open up this one, you'll see instructions on installing Docker on Ubuntu. Basically went through and ran these steps here. That gave me my container environment. And the last step was to actually install kubeadm, kubelet, and kubecontrol, and they have instructions here, and it worked fine. And then you get to a point where you basically have on both machines sort of ready. The cluster doesn't exist yet, you just have the tools in place to create the cluster. The last step here is you need to actually go through the exercise, and there's different options. They have instructions for high availability options. We're going to create the simplest version, which is just a single control plane. So there's two instances. One will be a control plane node or the master node, which only has, it won't host any of our workloads. It'll only host that which supports the kind of the cluster itself. And the second instance will be a worker node, which has no control plane on it, and it only hosts the worker processes or the workloads. Okay, and the main step here is, let's see if there's anything tricky in here. Well, the only thing that's really tricky in here is there is a step here where you need to, let me go through here. There's a step right here. You basically need to, this step right here. When you use, the command you're going to run is kubeadm init, right? So the last step here is basically kubeadm init, and then you pass any arguments. And one of the arguments you're going to need to pass is this pod network CIDR. And what you want to do is, what this is basically, the way that Kubernetes works is that all your like pods, your various resources actually consume IP addresses. And that's how sort of the internal networking works, is with everybody having IP addresses. And one of the things you need to do is specify what subnet those IP addresses are being drawn from. And you want to make sure that that subnet that you provide to this command, this option, does not overlap with your Amazon address space. So Amazon uses, I think, a 172 blah 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 subnet. In this case, I used one of the. Okay, so another thing you'll do later on is we're going to have to install a pod network, if you remember that from before, and we're going to use the Calico one. And if you look down further, sorry to jump around a little bit, but if you look at the Calico setup here, they warn you that you should actually install Kubernetes with a pod network CIDR of 192.168.0.0.16, since that's the default subnet or default network that Calico expects to be in place. So this is basically the command line option that you need to provide when you run your step, which is kubeadm init, and then you provide that argument. Okay, so yeah, you basically, all that's basically to say that that's what you need to do. So you run that command, it will spin up and do a bunch of things. It'll give you further, once it's done, it'll give you further steps to finalize the installation as part of that instructions. So again, I'm not going to do this on the screen. And you basically at that point have a cluster that's operational, at least up and running. The last step is actually to go back down and actually install that pod network, right? And we're going to use the Calico, so you basically follow the instructions here. You just run this command right here, and it will install the Calico add-on to allow for pod networking. And now you've got a fully operational cluster at that point. So make sure. Yep. And and then the last piece of this puzzle, you'll have one of your instances will be on the cluster. Your second one you haven't done anything with. In the output of the first installation on the master network, on the master node, it'll give you instructions on how to join the master from the worker, and you just basically log into, you copy that command line, which is like kube, ADM, join, some hashes and whatnot. You copy that, you paste that onto the worker node, and the worker node will join, and now you have your fully operational cluster with the master on the first box and a worker on the second box. So that's where we're going to pick up sort of our exploration, right? And so let me just log into my instance here. So I'm going to secure shell into my Ubuntu instance, which is my master node. And this is pretty much after install is fully working. And see kube control get nodes. Just make sure I have both nodes are running, my master and my worker, right? So I'm kind of done with my installation, and we're going to explore the installation a little bit. So the first thing I'm going to do is look at a diagram. This diagram actually comes from the official Kubernetes documentation, and it kind of tells you what under the scene it was installed, and we'll kind of poke at this a little bit more. So there's basically, if you look at our installation, we actually have 2 boxes, and there's 2, so one is our master, which has our control plane on it, and these are the main services that you'll see that we'll walk through one by one, and what they are and how to inspect them. And then each worker node only has essentially 2 things on it, kubelet and kube proxy, right? And again, we'll talk about what these are and what they do for us. Now, I guess one side note, our control plane itself runs on a node. So the control plane, the node that has the control plane also has kubelet and kube proxy on it because it's a node. So that's a little bit confusing. So the control plane is actually run on one of these nodes, and so that's why it has that also. But the worker nodes only have kubelet and kube proxy. Okay. So let me close this out. Okay, so I'm on my master node right now, and I'm going to look at a couple things. One is, if you, I guess, I don't know if it was in a diagram, but each of the nodes also has a container engine on it, right? And it has essentially has Docker on it. And we can validate this if I just type in, I'm going to run this as sudo. And if I do service ctl status docker, oops, hang on, that must be spacing out here. Give me a second, and now let me get myself regrouped here. Hang on. Yeah, I had wrote it down wrong. It's actually system control, and it's status docker, and you can see that this is definitely running Docker, right? So that's basically the container runtime. Every node has it, the worker node, the master node. Next is called kubelet, which if I do system control status kubelet, you'll see it is also running. So both of those, the Docker or the container engine and kubelet, both run at the OS level as actual services that start at startup. Again, and that's basically on all nodes. Okay. So next thing is, we also, if you look at that diagram, you will notice that kube proxy is running on all of the nodes also. And how we can see this is, I actually have something in my history here. I'm going to cheat here. I actually have, so I have a line here. Let me make this bigger. Plus. I had done this earlier, and I actually have it. Where is it? Let's see. Oh, I guess I don't have it here. Oh, yeah. Give me a second. Let me regroup for a second. I don't want to type out something that. Okay, give me a second. Logged in as root, so the history wasn't there. So I actually did this earlier. I ran a command here that said, this 199 box is my worker node. So it says get all the pods, which we haven't really talked about, but there's some objects of all namespaces, and look only on where the node name has this name, which is basically a worker node. So I'm basically looking at all of the pods, which for now we'll just think of as our workloads. And if I run that, if all's working well, what I'll see is I'll see two entries here. And again, one is the expected one that we just talked about, kube proxy. Kube proxy is running there. And I guess I haven't been talking about what all these things do, actually, now I think about it. Okay, so let me back up for a second. Okay, what did we talk about first? We talked about, bear with me. Here we go. Okay, so we talked about the container runtime was the first thing we talked about all the nodes having. And basically what the container runtime is just runs containers. That's like Docker, right? We talked about kubelet. We showed how to show that it was running, but we didn't talk about what it did. And it's basically a process that makes sure that all the containers are running. So it's kind of the bridge between Kubernetes and the container engine or Docker. So it's basically what on each of the worker nodes, it's what basically launches or controls, in this case Docker, to make sure that the containers are all running, essentially. The kube proxy, which we just looked at, it's actually, this is not running as a separate process, it's running as a container inside or a workload. It's called a pod. Think of it as a workload that's running inside of Kubernetes, and you can see it right here, this kube proxy. And what it's doing is it's basically integration where as you add services and whatnot or objects, there needs to be some changes to the network, and kube proxy on each of the worker nodes is responsible for changing the network to support basically all the communication across the cluster. So think of it as a networking integration tool. And then the other pod you're seeing here was installed as part of our add-on. So each of the nodes gets a Calico, basically a node and process, right? That is also kind of works with kube proxy to do the networking. Okay, so that was part of the Calico add-on. The next thing we want to do is look, so that's at the worker level. There's a lot more running on the master node. So let's look at that real quick. And I believe it's this one right here I'm going to run. Okay. So again, I guess the first thing you remember is the master node has the same thing that a worker node has on it. It has kube proxy, has a container engine, and it has kubelet. But it also has some other services, and then we'll go through these kind of one by one. The first one we'll talk about is Kube API Server. It's probably this one right here, right? And Kube API Server, essentially, its job is basically to expose the Kubernetes API. So it's sort of when you're running your commands, you're actually talking to Kube API Server first, and then its job is then to funnel basically to the back end services, whatever needs to be done. So it's kind of like the entry point for all the rest of the services. The next service we're going to talk about is Kube Scheduler. So Kube Scheduler is right here, right? And Kube Scheduler, it's responsible. So as you add new workloads, again, I'll say pods for now, right? It needs to figure out which node it's going to run on. And there's a lot of logic around deciding on where workloads go, and it's Kube Scheduler that actually implements that logic. So that's what Kube Scheduler is responsible for. Next one is called Kube Controller Manager, this one right here. Okay, and this is another part of and again, these are all part of the control plane, essentially. And this is, again, on the master node. Controller Manager is, as we'll learn later on, there are mechanisms to ensure that the right amount of workloads are running at any given moment, right? And again, these are actually pods, but think of them as workloads right now. And the Kube Controller Manager's job is to ensure that the proper amount of workloads are being run. So that's what Controller Manager does. And then there's another one called Cloud. Oh, actually we don't have it here. There's one that's not here that will be here if I was integrated with a cloud. So right now when we did this installation, by the way, this cluster has no awareness really that it's on Amazon. I mean, it's running on Amazon EC2 instances, but it has like no awareness of Amazon itself. It's just a bunch of boxes, just 2 boxes, right? So if I was integrated with Amazon, fully, and there's probably instructions to do that, but we're not going to worry about it because we're only use this as a learning, right? There would be something called a Cloud Controller Manager that would also run here, and its job is to do all the integration between Kubernetes and the cloud provider. So the kind of things that will kind of come up with that is that there's commands inside of Kubernetes where you can create load balancers. And those load balancers are actually provided by the provider, not by Kubernetes. And it would be the cloud controller that would manage that integration to the cloud. Again, we don't have it here. And then one more we do have here is this etcd. And again, I think we saw that earlier, but that's essentially the key value database, right? And you can see it's also running here, right? So this is like the example of a stacked environment where the Etsy database is on the same place as where the rest of the control plane elements are. Okay, and I think the only thing lastly related to this was that the last bit of business here is there were some other services that you see here. And one is, you see the Calico business. Again, that was because we added the Calico add-on, which was responsible for the pod networking. So when we did the last example, we were actually running a different kind of pod networking. The pod networking we did with EKS was an Amazon-provided pod network. And this pod network was provided by Calico. So you can see that there. And as before, we see core DNS now running here, which is allows us to use names instead of IP addresses for communicating across the as we refer to things in this network. So that was kind of a breeze through sort of installing and just sort of seeing the core services. And